I'm here with Pete Hanul from Virtual Incision. We've met on a webinar, but now we're actually seeing us full form live. Yeah,
Fantastic to see you, Tom. Thanks for stopping by the booth.
I get to meet Mira for the first time. I'm excited.
Mira is as starstruck as I was, seeing you live.
Very nice to meet you, man.
Wonderful. So this is all. This is a 2-pound robot.
Wow.
And it has its own robotic camera. Everything is made in-house. Virtual Incision itself. So it's a fully articulating robot. Articulates up, articulates down, left, right. So this will always follow your instruments. You can do that manually, or it can do that automatically. So this is all there is to it. The arms can move all the way up, all the way down, and as I said, your camera will follow you. This is disposable. This is disposable.
Okay.
So very easy. Quarter turn. And the other thing that is disposable is this little nest here. This piece, because that is got a seal, very hard to clean.
Okay.
But this and the camera goes to your sterilizer, and then it is reused, and that can be done 15 times over. So from a cost perspective, that helps us dramatically, cost of goods, and also that goes back to the end user, of course, the hospital, the administration, and the patient.
So take us back to the beginning a bit. Virtual Incision's been around since 2008, 2009. So you were born at a time when everyone was going big.
Yes.
What possessed you to say, no, we're going to go small. Everyone's zigging, we're going to zag. I mean, it makes perfect sense nowadays, but
yes,
it's hard to take that path less traveled.
Yeah. Well, we have a fantastic founder. Our CTO, Chief Technical Officer, is Shane Ferreter. Shane Ferreter is an MIT engineer who then went to work for NASA. And his first 6 years, he was instrumental on the first Mars rover. And Mars rover, the little thing that went up to Mars to experiment and to explore, the more you miniaturize, the more experiments you can send up into space, which is a good thing because it's expensive and not many of those rovers get to go up. And so that was his mindset, miniaturization. He went back to Nebraska to start a family, became a professor of mechanical engineering and robotics, and he struck a friendship with a surgeon, Dr. Dmitry Olejnikov. And between the two of them, they started thinking. Dmitry was working on the standard intuitive robot at the time, the big machines that you needed a wrench for. And Dmitry and he said, well, this is too big for what we need for bread and butter surgery. We need something that is more agile, more nimble, easier to use. And so the concept of miniaturization started, and they've been working on it for the last 20 years.
So is this a technical solution or an economic solution or a pragmatic solution and it may be all three, but what is the primary problem Mira was designed to solve?
I think to solve for the big footprint, the large setup, the need for, complex organizational, the infrastructure of the hospital, the training of the teams, just simplifying it. When you do cholecystectomies, hysterectomies, appendectomies, all those simple procedures, you don't need all the bells and whistles. So just to simplify it, it's almost like a robot. It's like a laparoscope on steroids.
Yeah, I was going to say. I mean, it's basically a surgical tool. I mean, it would find a home next to some other surgical tools very easily.
So I think as a hybrid procedure too, it takes up no real estate. It fits on any operating room table, any one. It just hooks up with a Martin's arm, and you can move it. You can move it around the abdomen. 10-second move. You can go from the liver to the spleen, to the left fossa, to the appendix, to the cecum, but in no time.
Okay.
Right? It sweeps up and down, as I said, 180 degrees. So the operative field that you have access to is actually quite large. So we've done a colectomy study for our de novo market authorization. 30 colectomies were done, 15 on the left, 15 on the right. All of them went flawlessly. And in those procedures, they had to reposition the robot in total 6 times.
Well, we have one set up. We want to show how it works?
Absolutely.